right, so this next one, we do have a situation that requires an absolute value sign. So this is going to be x to the fourth root of that. This is that situation because it's even and these two numbers are the same. And this one down here is the fourth root of y to the eighth. This is not the same situation because of there are two different numbers here. Okay, so what we have up here, x to the fourth to the 1/4 power is x to the first, but we need to put that in parentheses. Not parentheses, I'm sorry, absolute value sign. Here we've got y to the eighth, and it's the fourth root. So it's 8 divided by 4 is 2. So we've got that over y squared. Okay, so now let's simplify these, okay? These get a little trickier because we are dealing not with, we've got some numbers in here, but now we're dealing with variables. So let's look at this one, and we're going to look at it piece by piece. So the first thing is 4. Does 4 have a perfect fifth factor? No, it doesn't. So we leave 4 here. Now a to the eighth, I can rewrite as a to the fifth times a to the third. And since I'm looking for my fifth root, a to the fifth is a perfect fifth root. Or is a perfect, is a perfect fifth. So I can do the same thing with b, okay? A perfect fifth is in b to the 14th, it's b to the 10th, and then b to the 4th gives me the b to the 14th. So that's now a perfect root. And now we have c to the 5th, which is also a perfect root. So my final answer, oops, let's not do that one yet. Here's a perfect one, a to the 5th. So that's going to come out. It does not need absolute value signs because it's odd. Okay, then we have b to the 10th. Okay, 10 divided by 5 is 2, so b squared. C to the 5th is c, and I'm left with 4, a to the 3rd, b to the 4th. That's what I'm left with right here. Okay, so this one, we have a cube root, and we've got something in the denominator. So we need to get a perfect cube in the denominator. Well, I just had the perfect cube, some of them up there. But let's look and see what we need to do. So in order to get this to be a perfect cube, I need to turn this into maybe y to the 9th, because that's a perfect cube. So I can do the cube root of just y, and this gives me x times the cube root of y over y to the 8th times y. This is the cube root of y to the 9th. And that is a perfect cube. So this becomes x times the cube root of y over y to the 3rd. All right, and finally, with this problem, this is when we're using the properties of exponents, and we're kind of going back and forth like we had before. Okay, we've got when I say back and forth, I mean upstairs and downstairs. So 14 divided by 2 is the same thing as 7 over 1. So 7 comes up here. Then I'm going to pull this out and just look at it. I've got x over x to the 3/4. Well, I know that when I'm dividing, I subtract the exponents. So x to the 1 power is the same as x to the 4 over 4 power. So 4 over 4 minus 3 over 4 is 1/4. So I have x to the 1/4. Then I have y to the 1/3. That's just sitting there by itself. And then z to the -6. That -6 bumps it to the top, and that becomes positive. All right. So go ahead and try these, please. And go ahead and pause the video. Okay, this one is a nice problem because 27 is a perfect cube and q to the 9th is a perfect cube. So 27 to the 1/3 power, the cube root of 27 is 3. The cube root of q to the 9th is q to the 3rd, right? Because 9 divided by 3 is 3. Here we also have two perfect fifth roots. So x to the 10th, I take the fifth root of that, that's x squared. And y to the 5th, take the fifth root of that, is y. And I don't need to put it in absolute value signs because it's odd. Over here, I've got 6 divided by 3 is 2. And then if I take the x's out, I have x over x to the 1/2. Okay, so I can do x to the 2/2, same thing as x to the 1st, over x to the 1/2 is x to the 1/2. And then y, I have y to the 3/4 over y to the 1/2. Okay, if I subtract those exponents, then I'm going to have, let me write over here, y to the 3/4 over y to the 2/4, which leaves me with y to the 1/4. Okay, and finally over here, now I'm dealing with square roots. So do I have a perfect square in 9? Well, yeah, the square root of 9 is 3. How about w to the 5th? I do have a perfect square factor in there, and that is w to the 4th. You know what, let's put this all under 1. Let's do it that way. So 9 times w to the 4th times w. Here's a perfect square, there's a perfect square. And over here, I have the square root of w squared times w, and there's a perfect square. So when these come out, this is going to be 3w squared, those are done, times the square root of w, minus w, well this is going to come out and be w, so this is w squared times the square root of w. 3 minus 1 is 2, w squared times the square root of w. All right, that is what I have for you. Your assignment is in Big Ideas, and email me or put it on the discussion page if you have any questions.